Hi, everyone, and welcome to the ASPRS Mentors podcast. I'm Greg Stamnes, chair of the ASPRS Early Career Professionals Council, or ECPC. We also have with us Jordan Hicks, vice chair of the ECPC. And I guess just a note regarding next week's webinar. So that's the certification special, or focus on certification and answering all your questions regarding certification. So please get those in before next week so we can send them to the speakers in advance. And this week, our guest is Dr. Munjy. Dr. Munjy, are you okay with us recording this and sharing it on social media?
Yeah, that'll be fine. No problem.
Okay, thank you. Well, this week we're doing things a little differently. Dr. Munjy has created a presentation for us, so I'll let you take it from there.
Well, it's basically more or less bullets, but it answers many of the questions that you might have, and I would be more than glad to answer other questions as we go on.
Perfect.
So I'll be talking about my education, the positions I held, teaching, awards, licenses, professional societies, consulting, and research. So education, I got my bachelor's in science and civil engineering in 1976 from University of Baghdad in Iraq. And in 78, I came to Seattle and to study for my master's degree in civil engineering. Then I switched from civil engineering to study applied math, also in the University of Washington in Seattle. Then I went back again to civil engineering to finish my PhD. So I think it took me about 4 years and a half to do these 3 degrees at the University of Washington. Now, I think a question might come, why did I choose to be a civil engineer? When I finished high school, I wanted to go and specialize in math. But my dad is a civil engineer too. Advised me, he said, you will find nicer math in engineering. So pick engineering instead of math. So that's what I did. But then I had the opportunity to get more advanced in math while I was doing my graduate study. So I ended up with a master in applied math and then a PhD in civil engineering. A question might ask, why I civil engineer? I'm basically, my family is all civil engineer. My wife is a civil engineer. My sister is a civil engineer. My aunt is a civil engineer. My dad is a civil engineer. And now I have 4 daughters. The youngest daughter is a professor of structural engineering at California State University, Fullerton. So carrying the tradition of a civil engineering in the family is continuously going on. Positions I held, I was basically a teaching assistant at the University of Washington, Seattle. Then I got a job at California State University, Fresno in 1982. And in 1986, I was offered to go to Switzerland and work with a company called Wild or Wild. And some of you might remember that company used to be called, now it's called Leica. Leica bought that company, which is basically famous for surveying equipment and photogrammetric equipment. And then after that, I came back to the California State University, Fresno, where I became a professor there, and then head of the program coordinator, and then chair of the department, and then retired in 2022 after 40 years of teaching experience. And also I held positions in private companies that does research, which I might talk about it as we go on. The teaching experience in these 40 years that I taught, I think I taught close to 26 different courses. In civil engineering, computer methods and structural analysis, computing in engineering analysis graduate course, EIT, exam review, finite element analysis, static and strength of material, they are all in civil engineering. In computer programming, I taught courses in C programming, data connection interface, Fortran 77 programming, microcomputers applications, and surveying. Teaching GIS and digital mapping, I taught a course, computer-aided mapping, workshop at the ASPRS conference, digital terrain modeling, Geographic Information System, a graduate course, and design of a GIS, interferometric radar mapping, a workshop, and introduction to Geographic Information Systems, and a graduate course. In photogrammetry, I taught advanced analytical photogrammetry, which is a graduate course, airborne GPS control, AT, theory and practical concepts. From 1997 to 2013, we teamed up with Dr. Professor Mushtaq Hussain and Qasim Abdullah, and then since 2014 till 2021 with Qasim Abdullah. So you can see I have been involved with this workshop on GPS control AT from 97 till 2021. Also, I taught courses in analytical photogrammetry, close-range photogrammetry, I did a workshop in the University of Aegean, Greece in 1999, and GPS photogrammetry in the same university, remote sensing and image processing, and stereo photogrammetry. In surveying, I taught courses in electronic distance measurement, least squares adjustment, LS and SIT exam review, and plane surveying. The awards that I have been given, the latest one is the Outstanding Service Award. I got the Life Achievement Award, Fellow Award, Fairchild, Meritorious Service Award, and another Meritorious Service Award, all from ASPRS. I joined ASPRS in 1978, and till the COVID break, I have never missed a meeting of ASPRS, annual meeting, except one time when I was in Switzerland. But I was continually attending the meetings of the ASPRS conference, and that helped me quite a bit to advance my career and try to keep up with the advances in our field and the technology associated with our field. I get an award from Caltran Research Innovation Award, and this is basically many of the UC systems like UC Berkeley, UC Davis, they compete for this award, and I was able to get that in March 2004. And this is basically implementing GPS airborne triangulation. And the thing that we did the research, and then we trained the people at Caltran how to conduct the results of the research. And various research awards from our college at California State University, Fresno. Professional societies, as I said, I have been a member of ASPRS since '78 till now. I was the associate editor for theoretical and applied photogrammetry for the Photogrammetric Engineering and Remote Sensing Journal from '91 to '96. Chairman of the Close Range Photogrammetry Committee for '86 to '88. I'm a member of TRB and member of ASPRS Geospatial Data Standards that we just released, I think, last year. Licenses, I'm a registered civil engineer in the state of California since 1984, and also I'm a certified photogrammetrist at ASPRS. So I do teaching, I do consulting. I worked in a number of cases as expert witness for the state, and I did work for state, federal, and private companies. And also I'm the author of an aerial triangulation adjustment software called ESPA. ESPA, I was able to put that software in 1983 and it's still working. I think I have about 70 installations worldwide of that software. But it might be of interest to, in 1983, when I put that software, I did it on Data General, Nova 4. And guess what? How much memory this computer had? 64K. That's K, not M or G. So now I think that my last test with it, I was able to test it. I worked with 100,000 frames of bundle block adjustment on that software. Research, I have been involved with the research. So you can see I am basically, I have a tripod of professional work: teaching, consulting, and research. I did the data collection software for Caltran from 1988 to 98. For 10 years, they were basically, we developed that software to work on data collectors in the field. GPS photogrammetry research for the Caltran, we did the specifications for their AT triangulation, because Caltran has also a special requirement. Most of their blocks are strips, so there's more demand for control in a block formation. So we did the specification, and they put that as a chapter in their manual. In 1998, I was involved with the research with a company called Cargis, and involved in a consortium with that company, and they formed that consortium with JPL and the Department of Earth Resources in the state of California. to develop a dual side, dual frequency radar. So flying on a G2. This is an interesting project. Basically, what we have to do, we had to put an X band on the belly, transmitter and receivers, and the distance between them, 2 meters for the X band and 20 meters for the P band. So the X band, they had to measure it to an accuracy of 1 millimeter. So they put in a laser system between the two transmitter and the receivers and solve the problem. The P band, you needed to have the accuracy of the distance between the transmitter and the receiver to be one centimeter. And if you can, with the 20 meters, they have to put it at the tips of the wings of the airplane. And you can imagine as the airplane going to fly, the wing is going to go up and down. So we ended up having three GPS receivers, one at each pod and one at the belly, and a laser system measuring the distance from the belly to the pods on a digital camera. And all this data is being, with IMUs, of course. So 3 GPS systems, 3 IMUs, 2 laser systems, and 2 digital cameras, all trying to capture the flight of that G2. And they were all with different frequencies of data collection, so we had to use Kalman filter for that. So I was involved with that project for close to 10 years. My last research involvement is with Caltron, where we wanted to see if we can achieve the accuracy from UAV data collection. So we established a data field with 81 control points, measured with an accuracy of 1 centimeter planimetrically and 0.5 centimeter vertically. And we had different configurations. We checked the UAV with LiDAR and UAV with camera system. And I think if you go to Caltron website, you would be able to capture the report that we did that 2 years ago, I believe. So that's a summary of what I have done, and I am open if I miss something to elaborate for you as we go on.
Well, thank you so much. It was very comprehensive, and I was checking off my questions as you went through it. I did think of a couple though. One that I didn't have the opportunity to ask Dr. Qasim, what brought you from Baghdad to Seattle?
Okay. Well, when I graduated from civil engineering, my interest was in structures or geotechnical engineering. But then I got a scholarship. They said, if you want to get structures or civil engineering, you stay in Baghdad. If you go surveying, you can go overseas. So I said, okay, this is a good chance for me to come and study a new field. You know, when I came to the US, I have never seen an aerial photograph before. So what I did, I joined ASPRS, and then more or less bought all the proceedings that they had at that time, and I started going through them and reading them and educate myself so that I would be able to get through the courses and the requirement of the profession. So this is how much ASPRS has benefited me because of these proceedings that I was able to collect. So then I did my master in science to fulfill my scholarship. I had to do something in surveying. So I did the master in civil engineering, combining surveying, which is monitoring a Gaussian wall, and did a finite element analysis on it. So I used the surveying and the structural experience. And the MS in applied math, I basically developed a method that uses finite element method to do contour area interpolation. And that's how when I went to Switzerland, I was responsible for that program. And the program is called CIP. Until now, I think it generates one of the best contour lines in the field. And this is since '86. I think then Leica dropped selling Wild that time stopped selling the program after it was bought by Leica.
Okay, so oh, sorry. Go ahead.
Did I answer your question?
Yeah, for sure. Yeah, it's very interesting. So you talked about the evolution of software and I guess hardware tied to that. If you could predict the future, what are some emerging technologies that early career professionals should be aware of, and how can they set themselves up to get into those?
Well, this is a very good question. If we go back when I joined ASPRS in '78, what were they talking about? They were talking about, you go to the conference and session after session talking about bundle adjustment. They were not sure they can get the results with the bundle adjustment. Plus, they were just introducing analytical plotters, which we don't use anymore now. The profession has changed from the stereo plotters that they're using, the Kelch, the Kern PG2, the Zeiss C8. What else? B8, which, these are the tools that we use in photogrammetry. And today we are using all digital, relying on the digital part of it, UAVs. So on the average, I think I had to, because I had to teach these topics, on the average, 3 to 4 years, I have to change my lectures as I go on. So this is, and I expect the future is going to be with artificial intelligence, robotics, more involvement of computer vision in our field. We are going to see quite a bit of advancements as we go on.
Okay. You talked about the Caltrans specs for AT. Side note, I used the Caltrans specs for mobile LiDAR when I was developing a mobile mapping program at a previous employer, just trying to align with industry best practices and standards. How important are the ASPRS standards, and why and how can people advocate for them?
Well, you do have standards for mapping since 1947 or 48. But these standards were developed for paper type products. So, and the standards that we have released, basically it's for digital systems. So it addresses the camera system products plus the LiDAR products as well. And without the standards, how do you define the quality of the products? Well, I guess some people, they go and say that, oh, this product, this data looks nice, because they use their own type of different fonts, different line types. But the standard is going to give you the quality, how good is the data, and where it can be used to fulfill the requirements of that project. Plus, the other thing is going to be, if you don't follow standards and somebody would sue you, how you are going to defend yourself on what accuracy you have achieved to fulfill that type of contract. So the standards are very important, and I'm glad that ASPRS is taking the lead in that aspect. In the past, usually agencies like the USGS, US Corps of Engineers, used to define the standards for their products that are delivered by contracts. But now we see less involvement from these agencies because of the amount of funding that's available to them. So ASPRS took the lead in that. And the interesting thing with these standards, they were developed by professionals involved in the producing these products, from educators and from government and state agencies involved. So you get the experience of all these individuals in one place and try to address the issues involved with it.
Yeah, a collaborative approach from people with many different backgrounds.
Exactly.
Well, I've ran out of my questions. You answered them all, well, most of them with your presentation, so thanks again for that. Does any of the live audience have any questions? Looks like Greg has unmuted himself.
Yeah, I'm just kind of curious. You've been in the industry for quite a long time. I was wondering, everybody's saying it's evolving so fast nowadays. Do you feel like it's evolving faster now than it has been, or has it kind of been a constant rate of change for evolution of technology and standards of practice? And yeah, I'm just kind of curious because a lot of people are saying it's very hard to keep up with and a lot of new technologies coming out all the time, but has that been kind of consistent throughout your career?
Look, the basics did not change very much. So, for instance, I taught least squares adjustment for over 30 years, and that did not change much. But photogrammetry has changed quite a bit, and the development in the hardware and the software makes a dictate on us which direction we go. One of the notes that if you have been following my talk, I said when I was developing ESPA, the software the first time. How much did I have? 64K. Now you don't accept this to be on your hand now, that amount of memory. But at that time, we were dealing with, I believe we had the bundle adjustment was designed to go for 50 photographs. Now with the UAV, you get a system with a UAV going nadir and oblique. You collect thousands of frames. And you don't need to have a mini computer like the Data General number 4, but handheld, the computer can do the job. So our profession is going to change, but many of these changes is going to depend on the development of the hardware and software, and that changed the requirement associated with it. There are a couple of things, for instance, what I have seen on the UAV, on the LiDAR system. On the LiDAR system, I think one company introduced a laser system with 32 rods. Now, how are you going to calibrate that? Nobody is talking about it. So the manufacturer introduce a new product. Somehow the academia or the private companies, they need to find a way to calibrate that system, which would lead to new improvement in our approach to how to get better and more dense geospatial data. But definitely, artificial intelligence is going to open new avenues for our profession. Another example, I think it is going to change driverless cars. As we see cars driving alone, that's going to put more requirements on the accuracy of the data, plus all the data that are collected by all these cars that are driving. They are collecting all the information. We are not addressing this in a good way, but this is going to be challenging for us as we go on for the future. Any more
Thank you.
questions?
Any other questions from the live audience? I know Yusuf's got one. He's usually steering on one. I just gotta look at my list here. I might have. How about for people who are later in their career, or not necessarily later in their career, but are at the tail end of being an early career professional and are kind of, I guess, mid-level in their career? Should they consider continuing education? Potentially graduate level?
I think there's a tremendous needs for the USA to have PhD programs in geospatial sciences. if we compare how many PhD students we graduate from number of universities. So if I don't know, I'm going to compute it live. If I forget, let me know. Purdue, Ohio, Wisconsin, Penn State, Florida, maybe Maine. Did I forget anyone else?
I'm not sure.
And we are getting 1 or 2 graduates a year. Now, compare this with our neighbor in the north, Canada. They have programs, they have PhD programs in Calgary, in Toronto, and in New Brunswick, in British Columbia. Now, the other big challenge is going to be China. How many Chinese professionals are involved in the geospatial sciences? And if you look at our photogrammetric engineering and remote sensing journal, and look at the papers that are being published, is mostly from Chinese universities. So this is going to be a challenge for us to be able to get more the graduate program in geospatial sciences. Otherwise, we are going to get behind.
Do you have any recommended solutions for that? I've heard a lot in regards to even like the bachelor level education, that it seems that they're having a hard time attracting young people into even that level. And so do you have any solutions for either that or the graduate level?
Well, there's a solution, but it's difficult to implement, I understand. One of it is requirement for licensing for surveyors to have education, because that will put more students in the programs, and then also the educators are not going to be forced to teach 6 or 7 students in a class and then will be at the mercy of closing these programs, as we have seen in many of the universities around the USA.
I have a question.
Yes.
Thank you very much for sharing your journey. Really very impressive. And I like when you said that you have the three, the tripod, like the research, the academy, and the industry. And this is exactly where if somebody is only dedicated for one of them, they will feel like they're missing something.
Yeah, the tripod would fall.
Exactly. There will be no. Or I would say the grass is always greener, so people will be looking at different things. It's always like if you're doing only research, you will miss the teaching. If you're doing only teaching and research, you will miss the. So how did you manage to balance, like, the three things? And do you think you're lucky you're in a position that you were able to do the three, or anybody would be able to manage?
I was putting about close to 18 hours a day.
Okay.
So, but I want you to think about, I get my PhD in 1982 and retired in 2022. In 1982, we did not have UAVs. We did not have, we had products done on B8, build B8. I don't know if you have seen that. Or Kelsey plotters. Nothing about, we didn't have to know what is a bit and byte.
I see.
Now, as an educator, to stay for 40 years, I cannot come to class and talk about these old equipments. I have to update myself. And I think I mentioned that 3 to 4 years, every course I taught, I had to change, except the static in civil engineering. That's the reason it's called the static. It doesn't change.
All right.
But in our profession, 82, barely we had the concept of GIS coming through. And look where GIS took us.
Of course. Thank you very much.
So we have to keep developing ourselves. Our profession requires us to be on top of the new technology. And I liked what you liked with the 3 tripod, but I really believe it has to be like that. Otherwise, if you lack one of them, is going to be a recipe for failure.
I totally agree. Or frustration, if it's not failure. Thank you.
You're welcome.
You have to.
Oh,
Yep, you're up.
yeah. This is Jordan Hicks. I'm the vice chair of the Early Career Professional Council. This has been a great topic, and I appreciate it. For someone in the geospatial field who has not learned any computer languages or computer programming, what language would you recommend? The first language to learn, computer language?
Well, the first language I learned was Fortran, and it was on punch cards. I don't know if you know what a punch card is.
Of
I've
course.
seen pictures.
And so I learned Fortran, and then I taught myself C language, and then C++.
So ISBA was on Fortran?
What's that?
ISBA. Was it in Fortran?
It was in Fortran, and then I wrote it in C++.
Interesting. Very good.
Now, before joining this conference today, I'm teaching myself a new language, Python. So even if I'm retired, I'm still trying to work things out to be on top of the project. So I think a Python is a good start for the new people in the profession. But the concept of programming is that's what you need to learn, the if-else statement, the for loops. But then the syntax of each language can be learned without much difficulty. But it's important to know the concepts of the programming and the logic behind it.
Okay, thank you. Yeah, I agree. So, would you, going further, would you recommend learning like a high level language like Java or C# or C++ first, so you get the basics and understanding how these languages work?
Well, I'm not a proficient in Python yet, but I would say if somebody have not done a program and get into Python, he will not see much difficulty. But if he knows C or C++, it would become easier.
Thank you.
Thank you. We had J.R. Gregory had his hand raised there. Do you have a question?
These are great conversations. And I just wanted to add a couple of my own thoughts. I think the easiest starting point for someone being Python, trying to get into programming, I think is going to be more successful to keeping somebody in it at this time. I think going back to C, though it has a lot of benefits, and if somebody really wanted to pursue learning more, then obviously that would be a really great pathway. But Python's becoming really, really powerful today. It's open source. It's constantly developed. It's getting better and better. And there's a lot of tools out there, and it doesn't take as much effort to write the code because there's a lot of documentation on it as well. And then to go back to the previous question about how do we get people to get into the universities, and I really like that idea of making land surveying a career that requires a degree. As somebody who has spent most of my career more on the land surveying side, I welcome that, though there's going to be a big battle against that, mainly because the profession, the geomatics profession as a whole, is seeing less and less people, and we're starting to see more, a lot of like baby boomer era folks starting to retire, and it's leaving a big gap. And so I think across the board, what our profession needs to do more of, universities used to do this a lot more back in the day, but their budgets are tight now too. So I think the profession really needs to stand up and get out and talk to students K through 12. I mean, K through 12, you're not going to hit a whole lot of below seventh graders probably, but I'm engaging with local high schools where I'm at, and I'm going to go help out with a drone academy and a drone class, two different things coming up. I don't know what that's going to look like. I'm not the most qualified person, but I have resources to help me out to make it successful, and I think that all of us should be doing more of that if we can. Thank you.
Thanks, J.R.
Thank you. We have another hand raised here, Dr. Darian Grant.
Hi, everyone. Thank you so much, Professor Munjy, for sharing a bit of your journey. 20 years ago, I was one of your students at Fresno. I don't know if you remember.
I remember that. Darian, how are you doing?
Doing very well. I'm joining from across in the UK today. I just had a question on your journey. You've been involved in consulting. Maybe you can share how you got your first consultancy project and just how you got into that consulting area. I'm looking to do the same thing at the moment.
Well, the first consulting job I got, basically that challenge to put the bundle adjustment program on Nova 4 with 64K memory. So that was very challenging. We are located in Fresno, California, and the company was located in Irvine, California. So it's about 5 hours drive. Now, in 84, we did not have internet to link so I can work from Fresno. So I used to travel every weekend. Well, a Friday I did not have classes, so I used to travel Friday and get the work on the computer on the Nova 4 at night, because that during the day they have the shift working. So I work at night to compile and debug the software. That's how the environment we were working on it. Now, most of us like to work from home. So it's not a big problem, but at that time it was a big hassle too. So there was a lot of effort. I think the other thing that helped me get consulting jobs, I was making workshops like digital terrain modeling, area triangulation, and educating the people in the industry about the new methods of doing area triangulation. And then you start connecting with the personal people, and then that will do the consulting. I'll just give you another example. One time I got a call in 1994. I think a gentleman by the name of Brian Logan, I think Dr. Qasim Abdullah worked with him, called me and he said, I have a data, GPS data is not working. Can you see if you can find it, the problem? I said, well, send me the data. So he sent me the data. After a week, I was able to solve the issue. They had a block of photographs, and I was able to adjust it. And he said, well, that's not enough. You need to come to Maryland and show us how you solved it. So I flew to Maryland on a Thursday night, was there Friday, Saturday, and Sunday, because I have to get back to school. And we had a couple of meetings, showed them how we did it, and that to get me involved with the GPS photogrammetry involvement with our society. As you can see, I was more than 20 years offering the same workshop, but the content was changing continuously.
Thank you.
You are welcome, Darian.
Okay, so my question is about the how to attract people. Do you think like the digital twin, the gaming industry, the 3D gaming, the metaverse, and all of these things, because we're saying we're struggling. I think everybody needs geomatics. It's our job to go and tell people, educate people about this major. A lot of people, they don't know about the existence of such a major. And what JR is doing, going to schools and stuff, I think that's the only way to do it, is by attracting, because the market need, every single company have now a mapping department. They rely on map. Do you think this synergy where everybody now wants 3D, their expectation is high resolution and the autonomous vehicle, do you think this is going to have at least an impact on attracting people to study geomatics?
This question, we have been struggling with it for quite a bit of time. And I had to be on really the defensive side when I became a chair of the Department of Civil and Geomatics Engineering, because I was faced with you have the civil engineering faculty go to class with 35, 40 students, while the geomatics professor goes to a class with 6 students. So there's a lot of pressure. Why do we keep this program? And I'm sure many of the other universities, they get into that situation. It's not unique to our case. But what helped us in our case was there was a tremendous push from the industry. They use the industry here in California State. They give about $40,000 scholarship every year. In 40 years of experience, I did not buy, so I was not competing on the equipment budget with the other faculty. So basically, we had the equipment either donated or software. So the profession was involved quite a bit in our program, and that will help us overcome it. Now we do see increase in enrollment, so we are not talking about 8 students in the class, but 18 maybe students in the class. So there's some improvement. But the profession can help. We need to figure out how to develop the distance learning and take advantage of that in our profession. What else?
I've got a kind of a random thought follow-up to what you're talking about. Do you think the industry is its own worst enemy? And I don't know if I'm phrasing this right, but like software and hardware developers are making things easier so that anybody can pick it up and use it because they want to sell more software and hardware to everyone. But maybe that's like one of the catalysts for the low numbers in academia. Like, how can we address that?
Well, one of the criticism that I was faced with, or challenges, I would say, while I was teaching. While I was teaching least squares adjustment for a number of years, I had the students learn programming, so they go into the programming aspect of it. And I think maybe JR or Darian can jump in and give feedback, see how they learned from that. But basically, I have seen many times the students, they complain because of the programming aspect of it. They complain when they graduate, but when they graduate, they have a different judgment about how this was implemented. It is hard. I know some of the students, they did not sleep well, but it's rewarding. One of the ideas that came to us, which basically answers some of the questions you raised, is let's develop the class without the need of math. Well, without a math, how can you call this person as an engineer? We would end up with the drivers people. They drive a car, they don't know whether it is 8-cylinder or 6-cylinder or is electrical. They just go and put the drive and they keep driving. But if the car will stop, they don't know what to do, except maybe call AAA. But I think this is what the requirement that our graduates, they have to learn programming. They have to learn math. And they say, well, why should if I need to learn all this, why shouldn't I be an electrical engineer or a mechanical or civil? But I think in our graduate, the demand for our graduate now, each graduate, maybe when I was there, you might have 10 offers. That's how the demand on them now. JR, do you have something to add?
I do, and I put myself on camera because I'm wearing a Fresno shirt. What I was going to say is the absolute last thing we need in our society is a bunch of just button pushers. And then going back to Dr. Munjy's comments about school, I mean, it was hard. I took an exam with Dr. Munjy early in my career, and I failed it. I think I got like a 15%. I looked at that and I was like, wow, I'm in the wrong profession. But I stuck with it, and I kept with it, and ultimately towards the end of my career at Fresno State, I ended up passing the last 2 classes and got some of the best grades on the finals with Dr. Munjy. I learned a lot. It was challenging, but I think it's necessary to be challenged like that, because where there's challenges, there's failures, but then there's growth.
Thank you. I guess, Dr. Munjy, I feel like we could hold you hostage here for the rest of the day or the weekend, continue to ask you questions, but we should probably let you go. If anybody wants to reach out to you, if they have more questions, what's the best way to get in touch?
Well, they can email me. I think that's the best way of.
Okay. Thank you. All right. Well, with that, again, thank you very much. I liked your comprehensive presentation. It was a welcome change to our podcast. And thanks again. Thanks so much for doing this. I learned a ton. You probably watch it a few more times and learn a few more things. So thank you.
Thank you, everybody. Thanks. See you again.